Estamos con Morten Meldal, químico danés, profesor de química orgánica en el Centro de Biología Química Evolutiva de la Universidad de Copenhague y premio Nobel de Química 2022 por el desarrollo de la química click y la química bioortogonal. Muchas gracias por estar con nosotros en Medicina Responsable, doctor.
This is mine.
Para empezar, ¿qué representa para usted la química? ¿Qué ve en ella que el resto de los mortales no vemos?
Yeah, so all researchers, all scientists are looking for the unknown, and it appears in unexpected ways because the novelty is not something that you can foresee. You cannot really plan your research behind the desk and then go into the lab and do it. It's actually the observation of the experiments that leads you to new observations and new chemistries.
Precisamente eso que comenta de que es observa y no sabes a lo que te vas a encontrar, tiene mucho que ver con el premio Nobel del año 2022 que recibió por el desarrollo de la química del click. Es algo como lo que llaman la serendipia de la ciencia, que buscas algo y te encuentras otra cosa, algo diferente. No sé si nos puede hablar de cómo llegó a este descubrimiento.
At the time of the invention of the click chemistry, everybody in the world was working on trying to make combinatorial chemistry function. And combinatorial chemistry is really a method where you are making millions or many thousands of compounds simultaneously. So you need quantitative chemical transformations in order to do that. And we were looking, amongst all the many organic chemistry reactions, we were looking for reactions that would allow us to do quantitative chemical transformations. And one of these reactions turned out to be the click reaction. And it happened sort of serendipitously because we were trying to do something else. And then we observed the click reaction and we start to work on that. And it showed up to be exactly the kind of reaction we had been looking for.
No sé si puede explicarnos de forma breve y sencilla, si es posible, en qué consiste esa química click y qué supone para el mundo de la química y para el mundo de la ciencia.
Yes, mostly for science. So the click reaction really is like a molecular glue or Velcro, which allow us to take the existing chemical universe and combine it like it was molecular Lego. So we can put these building blocks together using the click reactions. And this has not been possible before because the normal reactions, they influence each other. So we cannot do, for example, put together two proteins by normal chemistry. We need things like click chemistry in order to do that. So it's a small glue tack that reacts with another glue tack and put them together. Nothing happens with the rest of the molecule. So that now allows us to do molecular structures we have not been able to do before with multifunctionality. So we can take one protein functionality, another protein functionality, and carbohydrate functionality, and link these together using click reactions, getting entirely new functional molecules which were not possible before. But not only that, we can use this click chemistry in so many different areas, like medicines, like functionalization of surfaces. Say you want to put on a antenna for light on a surface, you can put it on with click chemistry. So click chemistry is used in all sorts of gluing processes with molecular architecture.
¿Para qué enfermedades se ha empezado a aplicar ya este descubrimiento?
We are using it for development of new possible therapeutics. For example, we are working on trying to reduce the plaques in the brain. And we do this by making new molecules which are clicked together to maintain the structure, and they work by dissolving the plaques bit by bit. We work also on cancer, trying to make multifunctional molecules that can recognize a cancer cell, enter into the cancer cell and kill the cancer cell.
Durante la entrega del galardón se hizo referencia a que este premio está relacionado con algo que lo que hace es no complicar demasiado las cosas. Leo textualmente, decían algo así como sino en trabajar con lo que es fácil y sencillo, rompiendo la tendencia anterior que apostaba por procesos cada vez más complejos. ¿Esto qué significa?
Yeah, I think it's one of the first times, one of the few times that you see the Nobel Prize be given to something that makes life simple rather than complex. And this was the case here. Click chemistry is easy to conduct, and today you can actually, even as a biochemist with no experience in chemistry, you can buy the different components and you can stick together your biomolecules that you express in cells and so on.
¿Hacia dónde se dirige ahora el mundo de la química, el mundo de la ciencia, las investigaciones? ¿Por dónde van las tendencias?
So there are two things in nature that are very, very important, and one thing is molecular recognition, and the other one is molecular transformation, and this is carried out by biomolecules, in particular by enzymes. And so the molecular recognition, for example, by antibodies of your antigens when you are infected, and the enzymes which carry out things like processing your proteins in the body, making them, cutting them up in the right dimensions, activating them and so on. These are very important processes, and I think we are on the verge of really understanding those. So in my laboratory, we are designing entirely novel molecules that has nothing to do with the natural proteins, which also can carry out these processes, can recognize molecules and can process other molecules like an enzyme, like a protease. And so I think that understanding molecular recognition, understanding the principles of catalysis to the point where we can just design the catalyst we need, this is the future.
Es interesante especialmente de los dos campos que nombra, el campo de los anticuerpos, sobre todo con el tema de las vacunas, todo el desarrollo de las futuras vacunas. Incluso se habla ya de vacunas de enfermedades como el Alzheimer o el cáncer. No sé en qué punto están estas investigaciones y qué podemos esperar de ello.
We are going to see a whole range of new technologies in the health sector. So we have just seen the RNA vaccines, not that I particularly like the idea of immunizing with a single protein. I would rather have the full immune response to your virus or your bacteria, so that you get response to everything that the bacteria represents or the virus represents. But these kind of technologies will appear in the future, and I think that one of the areas where we really can gain something is if we find very selective enzymes that can carry out destruction of pathogenic proteins, for example. So if we can shed the protein from the surface of a virus with an artificial protease that doesn't harm our own cells, I think that's a great way to do treatment of disease.
Me interesa particularmente porque se habla últimamente de vacunas específicas para enfermedades tan complejas como el Alzheimer o como el cáncer. ¿Podemos esperar vacunas para estas enfermedades o es algo mucho más a largo plazo o incluso algo que no es posible que veamos?
Time will show these kind of communal diseases and non-communal diseases are very difficult to handle. Time will show if it succeeds. I think there's also opportunity in, for example, the GLP-1 analogs. So Wegovy, for example, from Novo Nordisk, which actually change the whole metabolism, your whole processing. It changes heart disease conditions. It changes probably also something about Alzheimer. So there's other ways than just the vaccines to treat this, and we will undergo some changes in the future. I don't know that cancer can be treated immunologically yet. I have not seen that it can, but it would be nice if it could. It is the way that we protect ourselves against cancer already, so if we can enhance that function, of course that would be the best. But there's never gonna be one magic way that we will treat all kinds of diseases. It's always going to be a conglomerate of different treatment regimes. including also making enzyme inhibitors, making signaling molecules that can interact with our G-coupled protein receptors, having enzymes, having antibodies and so on. All of that comes together as our health. So we'll never get one way that works for everything. Particularly with cancer, which is not one disease, but many, many diseases, depending on which kind of cancer, where is it located, how is it behaving. All of that makes the cancer different from one to the next, and you cannot have one vaccine that takes care of all of it.
El cuerpo es química, pero cada vez los humanos somos más reacios a tomar químicos, fármacos, bueno, pues por los posibles efectos adversos. ¿Qué opina de esta corriente que cree que tomar medicamentos, fármacos es perjudicial para la salud? ¿Hay razones objetivas, tienen razones objetivas estas personas para pensar esto?
I think there's always a weighing of side effects against effects, and in some cases it's simply necessary to take medication because otherwise you will not survive. In other cases, I think it's perfectly okay not to take your medication because you are actually have your own immune system, your own response. So that is a weighed decision that everybody has to take in any case. And the thing is, there's some sort of a worry about the new kind of diseases that are coming up, and in that instance, I think it's safer at least to take a little bit of the medicine against this initially to see what kind of reaction you have to it, and then you can go on with it if it's positive or not. But there's no such thing as good or bad chemistry. So I think that people who actually think about chemistry as being a bad thing have not understood anything about what chemistry is, because chemistry is everything around us. We are chemistry. We are made out of chemistry, and we would not work if chemistry didn't work.
En alguna ocasión ha comentado que la química tiene muchas cosas en común con las artes. ¿Qué quiere decir con esto? Porque en principio son dos disciplinas muy poco cercanas.
So chemistry is like art, where you have an artist imagining a three-dimensional space, putting it onto a canvas, or you have a musician who can actually see the entire work in front of him in his mind as sound waves and things. The same way an organic chemist at least works in three-dimensional space, knowing how the molecules look. They are actually interacting with each other inside your mind as you think about it. And you have the chemical reactions, you can see how the flow of electron density is and so on. So there's a lot of commonality between arts and in particular chemical sciences.
Muchas gracias por estar con nosotros. Muchas gracias.